Okay, this is our Blinky Data Bot. As you can see, here we have the Blinky. All right, this is the front end here. This is the back end of the Blinky. You can see the blinking light here in the back, which is why it's called a Blinky. The motion of the car will be in this direction. Also the other parts that are in this contraption is a light shade here, because the light will be the lens of the cell phone. This is the cell phone here. The lens of the cell phone is on the underside, about this region here, and there is some light, excess light that comes in that masks the image that you see on the phone. This here is a stopwatch that is affixed to the car by masking tape. So this is sort of low budget here. The stopwatch is started before the experiment starts. This is the image of the stopwatch that the cell phone sees. Okay, so the cell phone is seeing both the image of the stopwatch and the front of the car in this point. You see here the outline of the floor tiles here, and it's in a grid pattern. So you have a tile here, a tile here, a tile here. So this car is going to be moving in this direction. Every 10th tile, there will be a index card that is vertical at this point. So what happens is the car is going to be coming, the car will be coming in, say, this direction. As it runs in this direction, it's going to strike a index card that is upright at this point. The index card will then be seen in the video right here. When it strikes, that point on the image here is that point right there. So you can see the index card approaching the stopwatch, and then you see it strike the stopwatch at this point. So you have both time, which is here, and position, which is here. Okay, if this was if the index card was here, you would know this position, and you would know the time that the Blinky has struck that index card. Okay, and it's always going to be from the front of the car, so you don't get into the issues of starting the stopwatch in the front and stopping the stopwatch in the back. If you were doing this with two people trying to coordinate, one person with a stopwatch starting and stopping, the other person saying ready, set, go, or however you would normally do this with students. So this gives us really good control over the both position and the time simultaneously. So that you have this recording on the on the video, and you can slow the video down, look at this, slow the video down, see when it strikes the stopwatch, and then you can read the corresponding time. Okay. Now the stopwatch reads in 1/100ths of a second. The precision of the stopwatch itself is 1/100th of a second. The precision of your measurement is not 1/100th of a second. All right. It's a question of how well you can read that stopwatch when it strikes the card. Now the card may be, I tried to make them as vertical as I could. It might be slightly to the right, might be slightly forward, might be bent slightly backwards. So there is a little bit of slop in the precision of your measurement, right? So the precision is going to be greater than 1/100th of a second, probably not all that much greater than that. Okay. The precision in your position, right? The position is indicated by where it strikes along the index card is at this position along the tile, and that those cards are every 10th tile. Okay, so it's at the edge of the tile. So the precision as far as the length of the tile is concerned is certainly very small. But the length of the tile is from there, see the edge, the border here, from there to here. That's about a foot, but we're going to deal it in terms of tile lengths. Okay, so your precision of the uncertainty in the length is certainly less than 1/10th of a tile, right? And the precision of the time is certainly more than 1/100th of a second, but maybe 5/100ths of a second, something of that order. You will determine that by looking at the data that comes off the screen. Okay, you will see as you run through this, you will see um, that the image of the index card is going to be along this edge here. Okay, let me clear that. Doesn't look particularly good. The image of the image of this card will be like that as it comes as the card is moving. You will see this the top of the card coming towards the stopwatch here. Oops. It'll be coming towards the stopwatch at that point. On the left-hand side of the card is a number. It's going to be 0 or 10 or 20, 30, 40, 50, 60, 70, 80, and 90. Those are the positions in tiles. 0 will be your origin, okay? The origin is something that you as the experimenter decides, right? So I put the card down, that's marked the origin on the floor, right? That is going to, that position, that origin of position is going to correspond to the origin in time, which is not going to be 0. Okay, when it strikes the origin marker on the floor, the time is not going to be 0. I will start the card from maybe back here, right? Turn the stopwatch on, put the card on the floor. It starts to move. When it gets to the first, the first index card, which is marked 0, that will correspond to some time. So when the card is at the origin, at x equals to 0, if you will, the time will not be 0. Okay, but that doesn't matter. What we're dealing with here, as you saw on the last activity, what we are interested in is the difference in the time and the difference in the position. Okay, so the absolute time doesn't matter. It's the difference in the absolute time between positions. It's the difference in the absolute positions, which is the distance. Okay, so on the next activity, you will see the experiment in running conditions. Right, from along the floor, it goes from the length of one school to the other, and then a side view, so you can see it coming along, and then finally in the last view, you will see the actual data collection itself.